Today's video is going to be about arithmetic sequences and series. So arithmetic is a noun meaning math, but arithmetic is an adjective and it is describing the sequences and series that we are going to learn about. So first let's start with some definitions. An arithmetic sequence is a sequence in which the difference between any two terms is constant. So a difference is subtraction, or I guess it can kind of be addition, but the difference between any two terms is constant. And the common difference is the numerical difference between any two terms. The variable we use to represent this is a lowercase d. So I will do the odd numbers with you quickly, and then I will let you do 2, 4, and 6 on your own. But the directions say determine whether the sequence is arithmetic. If yes, identify the common difference and give the next 3 terms. So first let's look at number 1. We want to know what the difference between each term is. So from 5 to 8, we have 3. 8 to 11 is 3, 11 to 14 is 3, and 14 to 17 is also 3. Since these are all the same, yes, it is an arithmetic sequence, and D is equal to 3. So this is our answer. Now look at number 3. We have plus 1, then we have plus 1, then we have plus 2, and then we have plus 3. So this is just no. It is not an arithmetic sequence because those differences are not the same. If we look at number 5, we have plus 10, plus 5, and then we don't have to go any further. We already know that that's no. So you can go ahead and complete numbers 2, 4, and 6 now if you want. Or you can watch the rest of the video and complete those all at the end. So now we're going to learn the arithmetic sequence formula, and this is just going to make it quicker for us to be able to identify the nth term of a sequence. So we can identify the nth term, and that just means any term that we want. The nth term of any arithmetic sequence can be found using this formula. A sub n, meaning the nth term, is equal to D, remember that's our common difference, times n minus 1 plus A sub 1, where A1 is the first term and D is the common difference. Number 7 says to write a rule for each sequence, then find the indicated term. So in order to write a rule for this sequence, we need to find what D is, and we need to find what A sub 1 is. So in number 7, D is the common difference. So we want to see -5 to -1, we added 4. Then we added 4 again and added 4 again. And for these questions, they should all be an arithmetic sequence, so they should have a common difference in all of these problems. So D in this case is equal to +4. Then A sub 1 is just the first term, and so that is equal to -5. What we want to do now is write an equation. So we have A sub n equals D, which is 4, times n minus 1 plus A1, which is -5. And we want to simplify this. So AN equals, we're going to distribute the 4n minus 4, and then plus -5 is just -5. And then we're going to combine like terms to get 4n minus 9. So that's part of our answer, but it still wants us to find A24. We want to find the 24th term. So in order to do that, we're going to use the equation that we came up with. A24 is equal to 4 times n minus 9, and n is whatever this number is, so 24. So 4 times 24 is going to be 96 minus 9. We should get 87 for A sub 24. So that is your answer for number 7, both of those combined. Let's try number 9 together as well. Once again, we will need to find what D equals and what A sub 1 equals. So A sub 1 is always the first term, so that's just -6. Then to find D, we want to ask ourselves what the difference in each term is. So from -6 to -9, we subtracted 3. And then we subtracted 3, subtracted 3. So D is equal to -3 this time. And our formula is going to be A sub n equals -3 times n minus 1 plus -6. And once we simplify that, -3n plus 3 minus 6, and then one more step to get A sub n equals -3n minus 3. Then we want to use that equation to find A38 because that's what the question asks us for. So we are going to have A sub 38 equals -3 times 38 minus 3. So -3 times 38 is -114. Minus 3 is equal to -117. So A sub n equals -3n minus 3, and A sub 38 equals -117 are our answers. Now we have a little bit of a different problem. It says, if the given terms are part of an arithmetic sequence, write a rule for the sequence, then find A sub 12. So if we recall, our formula for an arithmetic sequence is A sub n equals D times n minus 1 plus A sub 1. So if we look at all the things that we have, let's see how far we can get. So A sub 1 is 3. So we know that's going to be plus 3 on the end. And then we are given a random term of this sequence. So if we were to put A sub 3 here, then that would mean that this n would equal 3. And then it tells us A sub 3 is equal to -7. So -7 equals D times 3 minus 1 plus 3. And now we should be able to solve for D. So we're going to subtract 3 from both sides and get -10 equals 3 minus 1 is 2, so I'm just going to have 2D. And then we'll divide both sides by 2 to get that D is equal to -5. So that's a piece of the puzzle that we're going to need. Then we now have both A1 and D, so we can write an equation. So A sub n equals D, which is -5 times n minus 1 plus A1, which is 3. So we're going to distribute the -5 and then combine like terms to get A sub n equals -5n plus 8. Now it also asks us to find A sub 12. So we're going to use that formula and plug 12 in for n. So we get -60 plus 8, which equals -52. So there are both parts of our answer. The next section is about arithmetic series. So we want to remember that a series is the sum of a sequence. So in finding the sum of an arithmetic series, you can use the following formula. We love when there's a formula. We don't have to do extra work. So the formula for this is capital S sub n equals n times A1 plus AN divided by 2, where n is the number of terms, A1 is the first term, and AN is the last term. All right, so let's find a sum for an arithmetic series. So let's remember first that our formula is S sub n equals n times A1 plus AN over 2. So we need to find what n equals, what A1 equals, and what AN equals. That will give us Sn. So we know that n is going to equal 10 because we are given that. We know that A sub 1 has to equal 2. Now we need to find A sub 10. And in order to do that, there's a couple ways you could go about it. One, you could just follow the pattern. But there's a different way we can do this that you may not, like if that number is really big, it might be harder to find that value. So we're gonna use what we learned in the last thing to figure this out. So if we know that A1 is 2 and it looks like D is equal to 2 as well, then our formula is going to be A sub n equals 2 times n minus 1 plus 2. This is D, and this is A1. And then if we just substitute 10 and for n, we're going to get that A10 is equal to 2 times 10 minus 1 plus 2. So 18 plus 2, which is 20. And now we have all three pieces to make our equation for this series. Or to find the sum, I'm sorry. So S10, the sum base 10, is equal to 10 times A1 plus AN divided by 2. So 20 plus 2 is 22. And then divide that by 2 is 11. So this is equal to 10 times 11, which is 110. And that is the answer that we are looking for. And number 16 is a little bit different. Number 15 is also different, but I specifically wanted to do 16 with you. Once again, we need to find each of the pieces to fill in our formula. We have S sub n equals n times A1 plus AN over 2. And we have to find n, we have to find A1, and we have to find AN. So this sum goes from 8 to 17. So to find n, we want to do 17 minus 8, which is 9. Then 9 plus 1 equals 10. So n is going to equal 10. And the reason we added the 1 is because so 17 minus 8 is 9, but if we write those down, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms, not 9. So that's where our 10 comes from. Then A sub 1 is going to be the value we get when we plug in our first term. So when m equals 8, we have negative 2 times 8 plus 3, which is going to give us negative 16 plus 3, which is negative 13. So A1 is negative 13. Then A sub n is when we plug our final term in. So when m equals 17, we get negative 2 times 17 plus 3. So that'll be negative 34 plus 3, which is negative 31. Then we can use all of this to solve for S sub 10 because there are 10 terms. So we're going to get 10 times negative 13 plus negative 31 over 2. This is going to give us 10 times negative 22, which just equals negative 220. And that is the final answer we are looking for. So I'm going to let you guys finish the rest of the worksheet. I hope you have a wonderful day.